So we're Team IO Recursion with the AEP challenge submission. So our initial exploration, we decided to use the decision tree sequential classifier, which essentially had 4 questions: if high energy was present, if a high energy incident occurred, if there was a serious injury sustained, or if there was a direct control present. And we had these high energy icons used to determine whether it was high energy. And then sometimes it didn't fit within those icons, so we had a graph that the model could use to predict. Initially, we thought we could use a tuple for each data point, with 1 for each question, 1 for yes for each question, 0 for no. We realized after testing on a sample that this was too expensive and inaccurate. So we decided to have the LLM answer each question separately. We use a locally ran LLaMa 3 LLM along with prompt engineering to answer those 4 questions and to label each data point with the label. And we tiered all these.
So in actually building the model, we realized that there's a number of different ways to classify the same natural language data. For example, there's a high versus low injury, there's a potential for injury, and we also consider the high energy classification such as gravity and motion. Since there's many different useful ways to make a prediction, and there's also many different simple ways to make a prediction, we ultimately took a holistic approach. So this holistic approach revolved around stacking weak labels. A weak label essentially is a very simple label. As you can see on the right, it's just a very simple method, which will just use some dictionary to assign a value for how much danger should be associated with this. It's very simple. There's very many of them. And this is just one example called snorkel weak labels. But we also use the LLM, and we also use cosine distance clustering. To visualize these labels, one thing we used was UMAP. So here's a 3D representation there. Another signal for the quality of our output is time series forecasting. So we know that electrical danger reports are very seasonal. Summer months are worse. And we can see here that there's definitely some circularity and some seasonality in our predictions. This is a good signal. Alternatively, we trained a neural network with PyTorch, and we were essentially able to translate the natural language embeddings to the magnitude model, and we were able to achieve less than a 0.14 mean absolute error on a data set with less than 0.2 a standard deviation.
So how impactful was this? Our solution was to eliminate all SIF in the workplace and target the highest value comments. And our solution allows a new message to be inputted in the same form as the CSV file. Realizing that this would only be useful for past data, we figured we could solve this problem. And another insight we had was that the higher energy value, no matter what type, there was a higher risk value associated. Here's a demo. So we input the parameters and then we get the classification here.
That's pretty good. You think so?